No. Okay. So then, so let's come back. It is a, it will again, it will take a time taken little explanation it is. So we'll see it is volumes. Volumes in generally in a Windows we see a simple volume. Simple volume means we are creating a partition. Earlier we call that one as a partition. Now we call it as a simple volume. Now the terminology change it to volume, that's it. But both are same. You're creating a partition or creating a volume, both are same. Of course, when you go to the disk part command, volumes are different and partitions are different there. Okay. So okay. Next one is a spanned volume. Okay. Next one is a spanned volume. What is this spanned volume? First of all, I will explain. Only these two things. See here it is. This is a single disk, and you want to create a partition in it. You want to create a small partition in it. Means you are dividing a physical disk into logically dif- uh, s- logically different drives, right? So what is we call these things? We call these are partitions. So here we call it as a simple volume. Okay. Next one is I have a disk. Okay. I have a disk. I have another disk. Okay. I want to expand my disk size into another disk. For example, mm, just like here I have some unallocated partition is there. For example, I have an unallocated partition is there. For example, it is a 50 GB. I inserted something a new disk. For example, here, okay, 100 GB free space is there here. Okay, 100 GB free space is there. I want to combine these two spaces like this. It means this completely. We have to put in a different color to understand this part. So total it become 150 GB unallocated. So I can make this one as a single drive. Okay, I can make this one as a single drive using spanned value. Okay, just like in another example I will tell. So same spanned value. So here it is, two disks are there. This is one example. I will give you another example. Two disks are there. One disk is 500 GB, and this is a 1 TB of disk, for example. Okay. Now I want to combine these two disks. I want to combine these two disks and create a single large volume. I will create a single large volume like a 1.5 TB of single volume, and I will assign a one drive letter. For example, it is a D drive. Okay, D drive now become, earlier it is a 500 GB only. Now it is become 1.5 GB. So this is called a spanned volume. What is spanned volume? Logically combination of two or more multiple disk. Logically combination of two or more disk. So logically com- combination of two or more disk, and and create a large volume large single volume without parity and disk failure. I will tell that what is the disk failure and parity. Okay, so without a disk failure and span volume not consider. Okay, sorry, not in ride levels. Just for a point purpose, I added. So I will explain the ride level next. Okay, so it is not in a ride level. So it is not a ride zero, not ride one. It is just not in a ride level. We can take any size of any disk. Sorry, any size of disk only. Okay, any size of disk, 500 GB, 1 terabyte, 1 terabyte, 1 terabyte, or maybe 1 terabyte, 2 terabyte, maybe 100 MB, sorry, 100 GB and 200 GB in a different disk spaces. Like we can combine those spaces also. That's why I given two examples here. Okay, so here there is a one, this is a disk one and this is a disk two. I have some allocated unallocated partition 50 GB and I have unallocated partition 100 GB from here. I can combine these two things and I can create a single volume also. Or I can take a disk one which is 500 GB and disk two is a 1 terabyte. I will combine like this and I will create a single volume also. Here also we can get a drive letter. There also we'll get a drive letters. Combination of disk spaces and we'll create a single large volume is called as spanned volume. Okay, why I told spanned volume separately? Because of spanned volume not considered as a ride. In ride anyway, I will explain remaining things. Next one is stripped volume and mirror volume. I will explain this kind of stuff. And next one is ride 5. Ride 5 volumes. These are volumes. Stripped volume, spanned volume, mirror volume, ride 5, ride 6, ride 10. These are the volumes are by a combination of multiple disks together and create a single large volume with or without disk failure. So next one is ride. Oh, what is a ride? Redundant array of independent disk or in a expansive disk. Redundant array of independent disk array in a expansive disk. Yeah, I'm now my mind is shaking. So this is what is the ride? Ride is usually combination of one or more means like multiple disks together and create a single large volume. First of all, next ride has a two types. One is software ride and hardware ride. Actually, when you say ride, like to Sai processor, like in the expert in working in organizations like production environment, so they don't go with the software. So they will say, no, it is impossible to practice. It is we need a ride controller kind of stuff because they're in an industry. They use hardware ride. Okay, so they use hardware ride. Usually for ride purpose we use a hardware ride only, not a software ride. Software ride is a secondary solution. It is. What is this hardware RAID? So we have a RAID controllers. Adapters are there. RAID controller adapters are RAID controllers on a motherboards, system motherboards, or in a scsi controllers. Okay, RAID controller is directly given, and a RAID adapters are there. Okay, or server motherboards, or scsi controllers contains RAID redefined. So I put a RAID full form, but actually, okay. So you can see the disk are connected like this. This is in a box, but earlier days, we'll go to images. So I will show you here. You can see multiple disk connection like this. SCSI controllers on it. If you already shown one NAS pictures right in Amazon, this is directly RAID controllers. Okay, so these are directly NAS or SAN boxes. Whether you NAS or whether you use NAS or a SAN, so RAID is a very simple concept to implementing on it. Just we need a disk connection, and we have to define which disk comes under which RAID level. That's it. Okay, so that is a hardware RAID. So directly we can get a RAID controller adapters. We will get it on motherboard. Also, we can define which disk consider as a which RAID, and SCSI controllers also there on board. SCSI controllers also having a RAID implementation options are there. Okay. Next, software RAID is by some applications. You can use some applications to, yeah. So, anyone asking question? Mm, okay. Okay, by using application, using Windows servers or Linux servers also, we can use it because it is server means itself an application type means operating system, and it is a software. So through that one we can define a RAID levels. Okay, RAID levels in a software levels is only for a certain level purpose only, not all purposes. Okay, so now we'll see what is this RAID levels. RAID levels are RAID 0, RAID redundant, array of independent disk. Yeah, correct only. RAID 0, RAID 1, RAID 5, RAID 2, RAID 3, RAID 4 is there, but not implemented for enterprise solution, not suitable for enterprise solution kind of stuff. They're implemented and they keep it. So we don't require. Next one is RAID 6 is also there. So what is a RAID 5 is a stripped volume. Another name of RAID 0 is stripped volume. Okay. And RAID 1 we call it as a mirror volume. RAID 1 we call it as a mirror volume. So remove this volume part. Okay, we'll keep it then. RAID 5 is a RAID 5 only. RAID 6 is a RAID 6 only. There is a no other name it is. Okay, here write 0. First I will explain here. So I have a 2 days. Now I got a some shortage of disk space. I got a shortage of a disk space. So now what I've done, so I'll combine with other days. So then I increase my drive space. Disk space or a drive space, you can say. For example, this is my D drive. The first disk is my D drive. Okay, first disk is my D drive, and this is the disk one. Okay, so I have a some size and a just I'm directly telling it disk wise, not a some part of the disk. Okay, so I'm taking as a some direct disk. This disk is for example, it is 1 terabyte of disk space is there. Now I put some data in it, and my disk is about to fill. I cannot purchase new disk. If I purchase it also, I have to transfer all their data to there, and I have to assign the D drive to it. Normally, in our system, see, in our system, whenever my, for example, E drive is full, then I will go to F drive or G drive. So see, G drive is less. You can see G drive having a less space. If you see E drive is almost 103 free available, but it is a 27 GB available. But it is here 181 is available. Okay, so if in case if this is full, I will store data here. If this is full, I will store the data here. So wherever your data store, we can access. For example, this is my H drive. When I create a virtual machine, automatically virtual machine should be created in a H drive only. When I download something, download should go to my G drive. I define like that. So like that. So what happen if you add an extra hard disk? If you add an extra hard disk and you want to store data, it become another drive, not D drive. Now I have a D drive 1 terabyte. Now I need more space, add an extra hard disk, but it become other drive. Maybe E drive or F drive, it become other drive, not a D drive, right? So I will always store in a D drive. My folder is in a D drive, so I can't expand my storage. Okay, it is not like I'm expanding my storages, right? So I inserted another disk, and I will combine the disk together. So here in this one, both disks should be same size. There's a ting ting. Okay, both the disks are same size, and I will tell these disks together, so it become single large size. Means earlier my D drive is 1 terabyte. Now my D drive is 2 terabyte automatically. So this type of thing we call it as a stripped 1p or double p, anything you can put it, no problem. Just stripped volume, and the write level we call this one as a write 0. Okay, so this is called we can get a use like a combination of two or more days to get a full volume. Two or more days to get a full volume. So means so to large single volume, combination of two or more days to get a volume. Here it is. We get a large days like a combination of two or more days to single volume. This is without disk failure. No disk failure. I put a simple no disk failure and no parity. No disk failure, no parity it is. So again, I will explain here only everything. So then we'll particularly in one single notes. So this is again another disk. So I'm going to write one now. I have another disk. Okay, so this is the disk one. So here in the stripped volume, um, the stripped volume, if any disk is failure, for example, disk 2 is failure, total data loss. If any disk is failure, total data loss. Okay, disk 1 failure, total data loss. So like you combine 10 disk, one disk is failure, you can't access the data. Data loss means you cannot access the data at a time. You get a 2 terabyte of disk space, but if one disk is failure, users cannot access the data from it. No data access. To, for example, when we are working in office environment, just what happened, our main office system is there, one system desktop. Two times the disk is failure, two times the disk is down. I don't know why the disk will always failure, but the company are a cheap quality that one. So the vendor is given the cheap quality things, it's keep failure. Okay, so even the company people, if you go and that is a 500 GB hard disk, if you go to the company after 3 4 months, they will give you 360 very old hard disk, 320 GB only, like that. It is happened. Okay, um, so I have a data, very important data, students data, maybe some application related data, or maybe fees collection data is there. If disk is failure, you can't able to access the data, right? Of course, even if you have a backup, compulsory backup is required, but backup restoration will take time, right? I have a backup and I will restore it. That one means you have a, for example, 1 terabyte of data is there, 1 terabyte of backup. To restore it, it take lot of time, but immediate access is required. So even if one disk is failure, for a normal PCs, for normal desktops, or a less cost solution is mirroring. Mirroring means, for example, have a D drive again. Means drive letter won't changes here. That's one important to remember. This is my 1 terabyte of disk. This is a 1 terabyte of disk. Okay. What are the data I stores here? What are the data I store here? So means if I store a data here, same data stores in another disk. Understand? What are the data is stored in one disk? Same data will stores in another disk. Okay. So the combination of two disks is the result one disk space only. Okay. So this we call it as a mirror. What is mirror? Combination of two disks and we'll get a single disk volume. If one disk is failure, still we can able to access the data. Data can be access is available. So the write level is write one. So uh, what happened? Write one. So this is we call it as a combination of two disks, single disk, combination of two disks, and create a single volume, and it is a single disk failure. Understand the disk failure thing? If disk is failure, one disk is failure, like a disk 2 is failure, no problem, still we are getting access of data. And no parity bits. Okay, so I will explain parity bits in a RAID 5. So this is a RAID 1, these are called as a mirror disk, mirror volume, and combination of two disks will get a single disk size only. Okay, and it is a single disk failure, means one of the disk is failure, still you can able to access the data. So next one is, here if you see one disk is failure, another disk is still we can able to access the data, but it is not a enterprise wise. It is like enterprise required more large volumes, and as well as disk failure thing. If one disk is failure, if I insert a new disk, so that the mirror will should create a new data in it. So but it won't happen. Mirror will break once disk is failure, mirror will break. We can access data, but mirror will be break. So that is in a mirror disk. Maybe you confused. I will explain it again. So don't worry. This is a one disk. This is another disk. Okay. Here I took a three disk. Two or more disk we can able to, sorry, not two or more, three and more disk we can take it here. So it is a RAID 5. I'm going to create it. Um, Again, this is the disk one, because no practicals, no, that's why I'm just struggling to explain. The practicals are there one way or other way, you will easy to understand, at least we can see those things. Okay, so this is the D drive, 1 terabyte of disk. Why I'm taking same sizes, compulsory, either complete disk it should be same size, or more than it one. For example, this is 2 terabyte, this is 1 terabyte, 1 terabyte. From 2 terabyte, it will take 1 terabyte directly. Okay. So disk is, for example, any volume. So for example, this is 2 terabyte and this is 1 terabyte. Now I want to create a strip. So what happened? This size only. It will take 1 terabyte from here. It will leave the 1 terabyte. It won't take this 1 terabyte. This will take 1 terabyte only. Lowest disk equals with the lowest volume, not a disk, actually say lowest volume, means out of three, which one is the lowest size, it will take that size equally from other disk, for example, here is only 100 GB is there, and creating a RAID 5, then 100 GB, 100 GB, 100 GB only. Okay, so to avoid the confusion, that kind of stuff, just I'm taking equal sizes, directly disk as a equal size. Okay, now this is combination of three disks or more, we can create a single volume. We are creating single volume. Here I'm getting the total size is, here I'm getting total size is 2 terabyte only, not 3 terabyte. Okay, so just why I'm writing here, so here two disk volume you are getting, here single disk volume you are getting, here 2 by 3 disk volume you are getting, means out of 3 disks You're getting volume size is 2 only. Okay. Next, this is like a single disk failure. This is also single disk failure, but with parity. What is this parity thing? Is like this. Like this. I need some color to explain. Okay. So what is this parity? Parity means, um, here I put some data in a disk. I put a data in a disk, and the data in one disk and in other disk, data's parity bit will stores. Data's parity bits will stores. Okay. For example, here is a data is there. This data parity stores in a other disk. Parity means it is nothing but a data only, but it is a format. It's a different format, means a simple compressive format type only. It is from your data. It is like a, if you write one here, it write a zero others place. Okay, so it is a lightweight data than normal data. What is the advantage of writing a parity bits of your data into other disk? Is very simple. We can say, if one disk is failure, for example, disk 2, disk 2, right? This is disk 2. Disk 2 is failure. Disk 2 is failure. Now I check it. Okay, still data is access. One single disk failure means one of the disk out of three, one of the disk is failure. No problem. Data can be accessible. Data is there, safe. But you can't keep it like that, right? I remove the disk, I reinserted a new disk. I removed the disk, I reinserted a new disk. Okay. Now what happened? The disk 1 and the disk 3 regenerate the data into new disk. Then it will maintain this data equally. That's why only two disk size we are getting. Okay. So again, I will tell, what are the data stores in wherever the disk data is storing currently. The data's parity bits will stores in another two disk. Okay, so data can be in any disk, in any time, but their parity bit stores in a other disk. So if any disk is failure, no problem. When you replace with a new disk, the data will be regenerated into the disk, and the change of new data also will be generated into the new disk. So that is the main use of this parity bits. So it is a enterprise solution. It is a enterprise solution. Okay. So if you have a data, then their parity bit stores in other place. Okay, it's a single disk failure with parity. This type of storage we call it as a RAID 5. RAID 5 don't have any other name, just it is the RAID 5 name is RAID 5 only. Of course, as I said, RAID 5, three disk we are used generally, but if you add five disk, then what happens? Okay, these are three disk, so RAID 5, then I'm adding two more disk. Okay, so each one is a disk, like I will put a sizes only 1 TB, 1 TB, 1 TB, Disk 1, disk 2, disk 3, disk 4, disk 5. Five disks are there. So volume like a something like a D drive. Okay. The resultant volume is here 5 disk I'm using. So total disk space I will get 3 terabytes only. Okay. Not 4 terabytes, not 5 terabytes. It is I'm getting 3 terabytes. This type of RAID level is RAID 6. It is a 2 disk failure. 2 disk failure with parity. With a parity. Okay. So this is a RAID 6. Same concept of RAID 5 only. Okay. The same concept RAID 5 and RAID 6. If you use 5 disk in a RAID 5, it become RAID 6 automatically. RAID 6 option is not there in a software RAID in generally. In a Windows server, we don't have a RAID 6 option. But you want to create a RAID 6, you can use 5 disk and you will get a 3 disk volume. Same concept only. Other than this, there is other rides also there, like a ride 10, ride 50 also there. Ride 10, it means it's a combination of ride 1 and ride 0. You can't configure in a Windows servers kind of stuff. Um, direct option is not there. Direct option is not there. Okay, but you can create it. So ride 5 and ride 0. Okay. It meaning is ride 1 mirror, ride 0 stripped volume. So you create a mirror, mirror, strip, or a strip, strip, mirror. It's just like here. Um, just um, I don't have a spaces, so that's why this is a volume, and this is another one. So I strip volume. This is like a so one strip volume here. It is will take something. Okay, this is one. Okay, and I take this one, and this is another strip volume. Okay, strip and strip, and I started mirroring in between that one. So for example, I'll take this one, mirroring. Colors are different, and actually if you do practically everything in a different color, strip will different color, mirror in different color, just for understanding. This is ride 0, ride 0, and I combine ride 1. It means if one of the disk is failure, this total volume is failure, but still we have a volume space. Same ride 5. So write 0 in each. This is write 0. Write 0 means 2 disk, 2 or more disk, 2 or more disk, 2 or more disk, and combined with the write 5. Okay. So both are there. So I'm going to write a notes. I think you are cleared or not, I don't know. So if you are clear, please tell me. If you are not clear, also please tell me. Write 0 is a stripped volume. That is I have written earlier already. Next here we use 2 or it is nothing but a combination of two or more disk. It is a combination of two or more disk. It is a combination of two or more disk. And create single large volume. Okay, and next, if any disk fail, any fix, so cannot access data, and also called as, okay, total data loss. It means we can't access any data, not even from a one disk also. So two disks are there, one disk is dead, and another disk still alive, but that disk data also we can't access. So total data we can't access. Okay. Next, stripped volume, combination of two or more disks, and create a single large volume. No parity, nothing. Only for this is only used to create large volumes. Okay, only to create large volumes without parity and disk failure. Means disk is failure, problem. Next, ride one. Ride one is also called as mirror. Okay, so before you plan for a mirror, means like I want a mirror, it means you have to take a fresh disk. For stripped volume you don't require a fresh disk, but for mirror you need a fresh disk only we can able to do it. So that disk without a data, so we can able to create a mirror. Of course we can add mirrors also later, so possible. We use two disks here, and we'll get, it is a combination of two disks, and create single volume. Okay, so here we will get a single disk size only. So example, take 1 terabyte of disk plus 1 terabyte of disk, then it is equals 1 terabyte only. Here is an example. Okay, you take 1 terabyte of disk plus 1 terabyte of disk equals 2 terabyte of disk. But here you are getting single disk size only you are getting. Next, it is a single disk failure. Dot parity means if any disk, any one disk, not any one, birds are, if any one of the disk fail, still fail, still we can access data. Okay, so this is about mirror. But there is a problem is there, one disk is failure, still we can able to access the data, but mirror will broke easily. Mirror will go to, will broke. Okay, last time it is not broken, that's why I'm not confident. Usually when I use earlier, so earlier versions of Windows Server, so one disk is failure, automatically mirror will broke. So I put a possible mirror broke, BRO, mirror will broke if you replace this failed disk with new. Okay, so that's the another one. And almost 50% of size you are not getting. So that is another one. So you are getting 1 by 2, 1 by 2 disk size. Yeah, remove this one. Guys, are you understanding or I'm just mind is out? Means, usually we are trying to concentrate, but what happens? Sometimes mind will go to some other places because of some example or because of continuously feeding. We are not machines. It will take time to get inside a mind. Are you understanding or not? Please tell me that is. Okay, that is old message. Is that as a backup? Very good. So finally, one question: is that as a backup? Actually, ride is not a replacement of ride is not a replacement of backup. Is not replacement of backup. Means backup is compulsory. You have to take it. So there is no replacement of backup. Also, not only ride, there is no replacement of backup. But see here it is. If my disk is failure and I have a backup, but I connect a new disk and I restore my data into the disk. Okay, so uh, from backup, I want to restore the data from my backup to the new disk. It take time, right? If it is a 100 MB, no problem. 1 GB, no problem. 200 GB, maybe it will take time. 1 TB, 2 TB, 1 petabyte. Think like a petabyte of data is there, right? So Google has a lot of data. So per second itself, it will create a terabytes of data. It contains a petabyte of data. Data centers in organizations like Google, Microsoft, Amazon, VMware, like this, like people having a petabytes of data or exabyte of data or maybe zettabytes of data or yottabytes of data. So that much of big data they are having. But every time they take a backup and they want to restore it, the backup is very difficult. So backup must be taken, of course. Backup must be taken, but restoration of backup will take time. So meantime, user cannot access the data, right? So right, we don't require for our desktop purpose in general, right? Mirror is okay, but right, 5 kind of stuff, 3 disk, can you put a 3 disk? So if you have a 3 disk, then you put all 3 disk for a storage purpose only. We don't put anything for a mirroring purpose, right? So mirroring or write file kind of stuff we don't implement for a user desktop purpose. But in a servers, large amount of data is there. For example, your database is there. It is connected to an application. Users are using an application. Your disk is failure. User cannot access data, and you user complaint, I can't able to access your site. Then you said, disk failure, I am going to replace the disk and restore the disk, wait for 1 hour. If you say like that, customer will kick you, right? The customer, user, whatever the name we are having, client. Okay, so client should access the data continuously, 100%, 100% uptime you have to maintain, both server services and storage also. To achieve this one, we are following right. Got the point, guys? Any other questions or anything? Okay. So it is not a backup. Backup should be taken compulsory by organization. Backup should be taken. But this is, if a disk is failure, no need to wait for a backup to restore the data. Still, you can able to access the data. That is important here. Okay. Here we take three or more disk. Actually, three disk we take it. Okay. Um, the combination of three or more disks to create a single volume. Logically, we are combining this one. Okay. Next. So we'll get a two disk size out of three disks. Okay. Means example, if you take 1 terabyte plus 1 terabyte plus 1 terabyte, you'll get a 2 terabyte volume only. So usually stick it to the three only. It's a three or three. Three become three. Okay. So important is here. It is a single disk failure. It is a single disk failure with parity. What is the parity? Parity is nothing but a simple data from your data only. We store the parity bits in a other disk. So a disk contains a data. That data parity bit stores in other disk. So if disk is failure, using parity bits we can regenerate the data. Okay, it is single disk failure with a parity. It means if any one of disk failure, any one of the disk failure, still we can access the data. Okay, still we can able to access the data. So that is right 5. Parity bits, a data in a disk, um, a data in a disk, and the parity bits of the data is stores in other disk. If a disk is, so let's see what is if when the failed disk replace with new disk, data will regenerate in new disk using parity bits only. Okay, so this is write 5. Next, write 6, same as write 5. So then we can remove a lot of points. Here it is 5 disk we use it. It is 2 disk failure. with with parity. Okay, so same explanation about it. If you want an example, so 1 TB plus 1 TB plus 1 TB plus 1 TB plus 1 TB. So 5 TBs are completed. So total size I took a 5 TB, but I will get only 3 TB only. So it is a 3 by 5 type. Okay. Um, 3 disk disk size of total disk. Okay. So total disk 5 disks are there. Out of 5, we are getting 3 disk size only. We are getting. Okay, with a parity, 2 disk failure, no problem. Still we can able to access. 1 disk is failure, no problem. 2 disk is failure, no problem. Like that. Next one is RAID 10. It is a combination of RAID 1 and RAID 0. Okay. So RAID 50 is also there. That is very rare cases people use it. So it's a combination of RAID 5 and RAID 0. So why we use a RAID 10, RAID 50 means you need a large spaces. You have a same regular interval of drives only there, 1 terabytes or only 2 terabytes only there. A lot of disks are there, but I need a more space as well as a redundancy. Understand? More space is required as well as a redundancy. What is redundancy? If one disk is failures, no problem, you can still able to access the data without waiting for a restoration of entire data or kind of stuff. Okay, so users should access the data directly. So this is about your RAID 0. So here I think I given a pictures also. So RAID is also noted here. So okay, so this is a PowerShell commands, and this is RAID. What is a RAID? It is combination of multiple disk into single logical unit to provide fault tolerance and performance. Disk mirroring, parity information can provide performance benefit by spread spreading disk IO across the multiple disks. Can configure using several disk levels. Shouldn't couldn't replace the server backup. Sometimes you can find in my ppt, so you can find some footnotes. Either it is a footnotes, or maybe you can find it in some links in the footnote. So when you see my ppts, please check the footnotes also, means notes, note part here. Okay. So this is a RAID 0. So here you can see A1 data is written here, A2 in another one, A3 here, A4 there. Without parity and mirroring, RAID 0. Stripped volume. This is mirror volume. See, both disk contains same data. Both disk contains same data. RAID 5, you can see each disk having a data, and parity is randomly stores in a different disk across all disks with the parity distributed across all disks. This is RAID 6. This is a RAID 1 and RAID 0 combination. So mirrored between RAID zeros. Okay, so this is about your RAID. Yesterday, guys, this is about RAID. That's it. I added some of things here, but I need to move on to backup also there. So first, I will finish that one also. So this is about RAID 5. write 1, write 0, write levels, kind of stuff. Do you understand right or not? Do you understand right? No, nothing, no, no messages, nothing. Okay, two people respond here. Okay, good.